Here's a video about standard deviation and z-score. So, let's talk about volleyball. Normally, the winning score is 25 points. Sometimes it's more because you have to win by 2, but think about during a volleyball game, your team, how often are they able to spike the ball? Pass the ball, set the ball, spike the ball. That's kind of our goal. Now, in a typical game, do you spike the ball 10 times? Is that the average number that you get? Sometimes a little more, sometimes a little less, but it's right around 10 or 12 or 14, or maybe it's 20 times, I don't know. Think about your team or a team and how often that happens. So, let's take a look at a set of data for 16 games and the number of spikes per game. Okay. Here are the number of spikes per game for 16 different games. Now, if you remember, N is the number of games we're going to look at. So that's the number of numbers we have in our data set. Now, let's take a look at the average. Now, if you look at these numbers, what would you think it is? What is the average number of spikes per game? Now, it's pretty spread out from low to high. So that indicates it might have a larger standard deviation, which is what we're going to get to in a second. But what's the average number? Take a guess. Okay. Well, it turns out that the average is 11. Now, it's not always a whole number. It just happens to be a whole number in this case. So 11 spikes. So we would expect to have right around 11 is our average. That's kind of, some are lower, some are higher. That's right in the middle. Okay, now, since we expect around 11, what if we have some really low numbers or some really high numbers? Is that really kind of weird compared to our average? And that's what standard deviation is. So let's talk about how do we figure out the standard deviation. So we look at how far do these numbers differ from our average. So this is quite a bit lower than our average. This is getting kind of close to our average. This is much higher than our average. And that's what we're really looking at with standard deviation. How do these numbers differ from these numbers on average? Okay? So, let's go to the next step. Okay, so here we have this. And so basically we're saying, okay, these numbers, right? All these numbers are a little bit below, lower than our average, and these numbers are higher than our average. But what's the average of these differences? That's what we're really after. Well, if we add them up, we get 0. So what we have to do is we have to square them all. Now, I'm not going to go through this whole process, but we square all these numbers, because we kind of talked about this before. Square all those numbers, then add that list up. Okay? Then what we do is we're going to divide by 1 minus n, so 15 instead of 16, which gives us a little bit of a cushion as far as our standard deviation goes. That's kind of how I look at it. And then we take the square root of that whole mess, and that gives us our standard deviation. So what that means is, how much do we tend to deviate from the mean? In other words, here's our average, but we could be anywhere 7.5 spikes higher than that or 7.5 spikes lower than that. That's how much we deviate from the mean on average. Okay, so that's what we could kind of expect. Anywhere between, 18.5 and, 2.5 spikes, something like that. So that's a very wide range because that's a pretty big standard deviation. It goes all the way from like here all the way up to, say, here. Any of these numbers is something that we could expect. Okay, so now let's talk about z-score a little bit. So remember, I'm going to say this one more time. Standard deviation is we look at how far do we deviate, how far do we differ from the average. Okay, and we tend to differ about 7.5 spikes from 11 on average. Okay. I know that might be a little bit confusing, but just keep working at it. Here we go. Let's talk about a z-score. Okay, so z-score is how many standard deviations is our score, or the number that we're interested in, away from the average. So let's take a look at that game where we only had 3 spikes. So I'll write down all the information. So our average, the middle number is 11. On average, we have about 11. So we had a game where we had not very many, only 3. And our standard deviation is 7.56. So we want to say, well, if we measured in standard deviations, how far away are we from the average, right? So 11 and 3, that's about 8 away, right? So it looks like we're actually over 1 standard deviation away below the average. How many in terms of these are we below the average? So I'm going to just guess that we're over 1 standard deviation below where we should be. So let's take a look at how we do that. So let's see, z-score. Hold on. So this is how you do it. You basically say, well, how far away are we, right? How far away are we from the mean? And say, well, how many of these go into that? How many of those standard deviations go into that number? That tells us our z-score. Okay, so let's do it. So let's take a look at this. Say you're the coach and you have a game and they only have 3 spikes. Now, are you going to go to your team and say, okay, we've got a major problem, or what's up, or what happened out there kind of thing? Well, we're -1 standard deviation away from the mean. Now, is that totally inconceivable that that would happen? Well, not in this case, because our standard deviation is 7.5 spikes. Okay? So that is how many we could deviate from this mean and still be kind of, it's definitely on the low side. It's not what we're looking for, but is it totally crazy bad? No, it's not totally crazy bad. That's what helps us with our standard deviation. Okay, coaches not yelling at athletes. That's what we're after, right? Okay, keep it positive.